when we draw a graph, we need to make sure that we have the following things ready at the start. We need a pencil, a ruler, a rubber, and a pencil sharpener. So the first thing you need to do is have a sharp pencil. The reason being is when you put your plots on, they need to be very, very, very close to the true value. Now, we're going to be looking at the speed of a treadmill and how that affects the heart rate. Whenever you get given a table, or whenever you draw a table, the independent variable normally goes on the left-hand side of your table. So the thing that you change in an experiment is the independent variable, and that's normally found on the left-hand side of the table. The dependent variable, which is what you are recording, is normally found on the right-hand side of the table. The first thing that you need to do is transfer the independent variable with the units to the x-axis. So this is the x-axis, it's the horizontal axis. So on this horizontal axis, we're just going to copy the independent variable down here. So that's going to be speed of treadmill. Don't forget the units. If you forget the units, you're going to lose a mark, and the unit here is kilometers an hour. We're going to be measuring the heart rate as a result of increasing the speed of the treadmill. Now, because this is the dependent variable goes on the y-axis, which is just here. And that's going to be heart rate. And don't forget the units, it is beats per minute. The next thing we can do is draw on our lines. There are bold lines and there are fainter lines on a piece of graph paper. When drawing your axis, it is better, it's not essential, but it's always better and easier to use the bold lines if possible. So there's my x-axis drawn on, and now here is my y-axis going on, always on the bold lines. The next thing we need to do is choose a suitable times table to fill up the x-axis. Now, the rule of graphs is it needs to take up more than half of the axis. So if we go up in ones, let's have a look. So we can go 1, 2, 3, 4, 5, 6, 7, 8. Well, that makes sense because we've got more than half of the paper taken up. I've not used these numbers here. I've used the 1 times table instead. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Now, advice when it comes to choosing a timetable for a graph. It's not essential that you choose the 1, the 2, the 5, or the 10 times table if they're small numbers, or the 10, the 20, the 50, or the 100 times table, or the 100, the 200, the 500, or the 1,000 times table, depending on what your numbers are. But it really does help when it comes to working out the numbers in between. You won't lose marks for using the 3, the 4, the 6, the 7, the 8, or the 9 times table, but it does tend to make it just that little bit more difficult when you're choosing where to put your plots. So let's take a look up the axis here. Let's go up in 5s. We go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. That doesn't fit. So you have to think, well, what times table will go into that? Let's try the 10 times table. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. Well, that is absolutely perfect. So that fills up the axis nicely. So we can actually go on the bold lines. You can see we've got the bold, and we've got the not so bold, and we've got all the other lines. And it always helps if you stick to the bold, bold, and the bold lines as best you can when scaling up your axis. Now we ignore these numbers now and we start from 0 because we always use the numbers in a times table. These numbers here that we've got will fit around our scaled axis. Now I see a lot of students might start at the bottom, they might go 63, 75, 88. That is wrong. It needs to be the numbers in your times table. So let's start from 0 this time. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. So if we looked at our x-axis, it takes up more than half the paper. If we look at the y-axis, it also takes up more than half of the paper. The next thing we need to look at is where we're going to place our plots. Now, when it comes to experimental design, I always talk about the independent variable first. So I'm always going to start from the x-axis. So when the treadmill is at 0, they're at rest. So their resting heart rate at 0 is 63. So we find 60, 70. Now if we count in between, we've got 1, 2, 3, 4, 5. So that is 10 divided by 1, 2, 3, 4, 5, which means each of these squares is worth 2 beats per minute. So 1 beat per minute will be halfway between these squares. So we can find 62, 64, halfway between 62 and 64 is 63. So we're going to put our first cross there. The next plot is at 2. So and it's easy because it's on a bold line. So at 2 kilometers an hour, the heart rate is 75. So there's 70, there's 80, 2, 4, and halfway between is 5. Now, I find it quite difficult with all these lines going everywhere to find where everything is. So we know that that 2 is on the bold line. So if we come to 2, 4, there we go, 5. That's easier. We can see, I'm just going to put it underneath, and then we know that 75 is halfway between. That's the wrong place. That's why we need a rubber. We are looking at 2. So let's do that again. 75, there it is, halfway between the 2 is just plotted there. The next one, 4, so find 4, and then that is 88, so 4 and 88, so there's 80, there's 90, take away 2 is 88. I'm going to use my ruler to make sure I get into the correct place. There's 88 just there, so just check the 4, 88. 6 is 101. So there's 100, there's 6. I'm not going to use a ruler this too because I've just got these nice 2 bold lines. That's between 100 and 102. And 8. The heart rate is 150, so I don't need it again. So I come up 8. 150 is on the bold line, not the bold line. And that is just there. Now, in the Cambridge exam board, you are required to join these up dot to dot. In all other exam boards, you use what's called a line of best fit. Right, I am not happy with this line here, so it's not quite entering that little cross that I put down here. Okay, so using the rubber, you rub it out, and then it needs to come from the middle of the cross just there. There you go. Much happy with that. So in order to score full marks, you need to have your x-axis labelled with units. You have a linear scale, which is a times table that you choose, that takes up more than half of the x-axis. The same is true for the y-axis. You have your label, what it is, and your units. You have a times table. Now remember what I said, it's often better to choose a 1, 2, 5 or 10, or a 10, 20, 50, 100 times table, but it's not essential, it just helps. That takes up more than half the page. The next thing you get marks for is making sure that each of these plots have been put in the correct place. So if 0 matches up with 63, yes it does, it's okay. So your teacher will check all of these against your graph, and then the final mark is for the line of best fit. If you get all of these things done just like this, you are guaranteed full marks in any question that you need to draw a graph with.